In between 40 question 6. Question 6, back when I was doing this, they call it scale drawing. I hope that's what it's still called. So scale drawing question. So it says the map represents 1 to 25,000. Determine the actual distance in kilometer represented by 0.5 centimeters on the map. So 0.5 centimeters on the map represents 25,000 centimeters. 0.5 centimeters represents 25,000 centimeters. 25,000 centimeters. 25,000 centimeters, that's actually, divide that by 100. Dividing that by 100 gives me, well, my apologies. 1 centimeter represents 25,000 centimeters. That's what they said. 1 centimeter represents 25,000 centimeter. So if I divide that by 100, I'm getting 2,25000 divided by 100. This is 250 meters. So 1 centimeter represents 250 meters. And so in reality, 1 centimeter is 250 divided by 1,000 is 0.25 kilometers. 250 over 1,000 is 0.25 kilometers. So this is what 1 centimeter on the graph represents. And so 0.5 centimeter is going to represent, to get 0.5, I need to divide this by 2. So 0.5 will represent 0.25 kilometers divided by 2. 0.25 divided by 2 is 0.125 kilometers. So 0.5 centimeter represents 0.125 kilometers. In other words, it represents 12,500 centimeters. All right, and that's that. The next part says calculate the actual area in kilometers square represented by 2.25 centimeters square on the map. Calculate the actual area in kilometers square represented by 2.25 centimeters square on the map. So to work out the actual area, right, to work out the actual area, then actual area in kilometers square. So first and foremost, 1 centimeter represents 0.25 kilometer. 1 centimeter represents 0.25 kilometers. All right. And so if I were to square both sides, then that would tell me that 1 centimeter square is going to represent 0.25 square. Now 0.25 square is 0.0625. That is 0.0625 kilometers square. And that's what 1 centimeter square represents. So to find out what 2.25 centimeter square represents, we multiply both sides by 2.25. So 2.25 centimeter square is represented by 2.25 multiplied by 0.0625. 0.0625. When we multiply these two, what we are getting will be 2.25 times 0.0625. That's 0.140625. So that is 0.14. It says the actual area, so I'm not going to round it off, just to keep it actual. 0.140625 kilometers square. Just to make sure I didn't reduce the actual answer. And this is what we get. Nice and easy, soft, very easy question. Nice. Now we're at part B. Part B says the diagram below shows the cross section of two cylindrical jars, jar J and jar Y. The diameters of jar X, my apologies, not jar J, that's jar X. Jar X, the diameters of jar X and jar Y are 3D and D. Initially, jar Y is empty and jar X contains water of height 4 centimeter. Determine in terms of pi and d the volume of water in jar X. Now, only thing I know is that volume is equal to cross-sectional area times height. That's all I know. Volume is equal to cross-sectional area times height. Cross-sectional area times height, that is volume. All right. Now, it claims that, this is what it claims. It claims that the cross-section is cylindrical. So if it is cylindrical, guys, if it is cylindrical, then what they're telling us is that it's cylindrical. It have a circle shape. So we need to know what is the radius. The radius R is very important to find in the cross-sectional area. So I think it tells us that the radius is what? The diameters of jar X is 3D. So the radius is, if 3 is the diameter, then the radius is 1.5. This is for jar X. And if the diameter D, the diameter is D, then the cross section for jar Y is going to be 3D divided by 2 is 1.5D, and D divided by 2 is 0.5D. So good now. So now we can find the volume. The volume, and this one is for jar X, volume is equal to the cross-sectional area, which is pi r squared times the height, h. So volume is equal to pi times the cross-sectional, pi times the radius r, but r is 1.5 d. R is 1.5 d. And then we square that and multiply it by the depth, h. This depth is 4. So that is the volume of jar X. So I'm going to call it Vx. Vx to say that the volume of jar X. So let's work that out. So when we work this out, this will give us the volume of jar X. And what we notice is that the volume of jar X is 1.5 square is 2.25, and 2.25 times 4 is 9. So the volume of jar X works out to be 9 pi times D. I don't know what these are, so it's volume of jar X is 9 pi D, and this is of course in centimeters cube. That's the volume of jar X. Nice and easy question. That's the volume of jar X. Now, it says that if all the water from jar X is poured into jar Y, calculate the height it will reach. All the water in jar X will be poured into jar Y. And what did they say? Jar Y is empty. So since jar Y is empty, then that means that the volume of jar Y is equal to the volume of jar X, because jar Y is empty, right? Jar Y is empty. So what they're telling us is that the volume of jar X is equal to the volume of jar Y, because jar X is empty. All right. Now they want us to work out what the height is. So the volume of jar X, which we just find, is 9. We just found that the volume of jar X is 9 pi d. And we understand why it is. No, the volume of jar X is equal to the volume of jar Y again, because jar Y is empty. And since jar Y is empty, then the volume must be equal. Imagine you have a jug of water and you pour out all it in another bottle. All right, then that means that the volume in this bottle is just the same as the volume in the original bottle, right? It don't matter the shape. So the volume of jar X, which was 9 pi d, is equal to the volume of Y, and the volume of Y, as we know it, is the area of the cross section times the height h. Now, the area of the cross section, we want to calculate the height it will reach. All right, so the area of the cross section times the height. So we really want to know what this height is. Now, the area of the cross section is going to be pi r squared. Then what is r? R is d. Wait, what was r for y? Oh, 0.5. So it's 0.5 d. So it's pi times 0.5 d, and then we square that and multiply it by h. All right, and that's 9 pi d. So now you're going to ask, what is going to be the height? All I need to do is divide both sides by, I'm going to divide both sides by pi times 0.5 d squared. When I divide both sides by pi times 0.5 d squared, that will definitely give me what h is. Just need to divide both sides by pi times 0.5 d squared. And that will give me h. So clearly, h is going to be equal to, put this in my calculator, the pi cancels the pi. Or 9 pi d squared. I knew something was off. It should be 9 pi d squared. Square it. When you square the d, you get d squared. You square the d to get d squared. D squared. So pi cancels pi, and so now it's 9 over 0.5. 9 divided by 0.5 squared. That looks like 36. That right? Let me check that. 0.5 square is up, yeah, 9 divided by that, that's 36. I'm getting that the height is 36 centimeters. All right, that's the height that it will reach, 36 centimeters. So if this is 4 centimeters, this will be 36 centimeters. And it makes sense because, you know, this have a wider cross section. And so this right here, it's so small, but it's longer. All right, so it makes sense. So the height is going to be 36 centimeters. So what is that telling you? It's better that you have a water bottle with a wider base. All right, it's better you have a wider base so that it look like it's little bit. Then you have a tall bottle, you fill it up, and as you gulp it, it finish. Because it just look like it's whole heap, but you know it's not really whole heap in it. That's just what I'm taking from this question. It's saying to you, invest in a wider base water bottle. But, you know, all up to you. Let's finish off